Welcome. If you're looking for an option to host your application while being able to use all of the sweet advantages Kubernetes brings with it, you surely ran into Microsoft's latest serverless offering, Azure Container Apps. To have an introduction for us on that, how it works and how it can be used, I'm happy to see our cloud native consultant Thorsten Hans with us today. He's one of those guys you want to have in your squad when your mission is to make use of top-shelf cloud technology for your application. So stay tuned for the upcoming roundabout 55 minutes. My name is Göran Homberg, and I'm happy to have you with all of you with us today in our first English-speaking webinar of this year. I hope you all had a great start into this one. Well, as always, before we start, I need a few minutes of your time in advance to have your short intro to the webinar platform to make sure you can make the most out of today's event. So just give me a second to share my slides and deactivate this footer. Here we go. Well, I'm seeing you guys are already using the chat. Please make use of it. Have a great interaction with everybody. Maybe just let us know from where you are attending. That's always very interesting to see. And as you can see in the slide, there's a Q&A section. This can be used if you want to place some questions you brought with you or you will have during the talk of Thorsten. We will take a few into the questions and try to find some answers after he finished his talk. If you get more detailed questions or want to have more in private chat with Thorsten, you can use our expert one-on-one. I will slide in the registration link for that in a few seconds. Well, you can use that time to discuss some questions or some thoughts you have about today's topic, or if you have other questions regarding Thorsten's skills, just go for it. It's really worth it. If you register, I'll reach out for you afterwards to find a matching time slot for you. After the webinar, we would be very happy if you leave us some feedback and please make use of the text box. Leave us a comment if you are interested in other topics or a more detailed run of that topic of today, or whatever you like. We are very curious about that. And if you have to leave a bit earlier, please use the context menu behind the three dots to the upper right and use Exit Webinar. That's the only way you get forwarded to the feedback form when you have to leave earlier. Well, that's all from my side. I will hand the stage to Thorsten. Have fun, see you later, and rock and roll.
All right, so good morning, everyone. Thanks for tuning in. Let me quickly bring up my slides, and let's fire up that in full screen. All right, as Göran already introduced, my name is Thorsten Hans. I work as a consultant at Thinktecture, and here I'm responsible for things like Azure, Cloud Native, Kubernetes, and infrastructure as code, mainly using Terraform, but in the last couple of months, we see bigger adoption happening when it comes to Project Bicep. So the infrastructure as code thing from Microsoft, that's also something I'm very interested in and using on a regular basis. If you have any questions about Azure Container Apps or any of those topics I mentioned, don't hesitate, just ask. You can reach out via mail or via Twitter. And from time to time, I write about those things also on my blog and on our company blog. So you'll find links also on the slide deck, which we will hand out after the webinar. All right, that's it. So today, all the things Azure Container Apps. So the latest addition to Microsoft's serverless cloud offering. And basically, it's serverless Kubernetes. So I have divided the talk in a few areas. So first, obviously some kind of introduction, what it is, why we have it, do we need it at all, and what Azure Container Apps brings to the table. Before we take a look at a couple of demos, so how we can actually bring our workloads into that new service, how we can provision it professionally, how we can do continuous deployment, stuff like that, and how we can, get some insights from workloads that are actually running in Azure Container Apps. Okay, that said, the most interesting question, obviously, do we really need another service to run containers in Azure? As you may already know, we have a bunch of services that are able to deal with containers so that we can take our workloads or our components, package them as a container and send them over to the public cloud and get them executed in some way. So is there a need for another service? And the short answer is yes, there is a need. So why is there a need? Well, basically, AKS allows us to do auto-scaling, right? So we can have our cluster, respond to actual load happening or coming in onto the system, so that Azure is able to bring up more worker nodes, so adding virtual machines to our cluster if there's high demand on our system, or to throw away machines if the load goes down. Although this is great and gives you some kind of, elastic Kubernetes cluster, it's not really serverless at all, right? Because we have to pay for the infrastructure, and so there is no serverless pricing. Let's say it that way. Obviously, Kubernetes is complex, and depending on what you're doing, it may become really complex very quickly, and so you have to train your developers, train your DevOps team to know what Kubernetes does and how you can react on events on a daily basis, so that you are able to take action if something happens. Real talk, in the last couple of years, Kubernetes gets really popular, and it makes finding people that really know Kubernetes really, really hard. And especially if you're looking for someone to hire, that's really complicated in these days. And if I recap the projects that I did in the last couple of years, sometimes Kubernetes is an overkill, because for having an web API, that talks to a database, and there is some kind of front end, like a single page application involved there, I think in most of the scenarios, there's no real need to have a full-fledged Kubernetes under the hood, to serve those components. So these are the things, or the reasons why I think Azure Container Apps is a great addition to the overall container landscape in Azure. So I've grabbed maybe the 4 most popular services when it comes to running containers in Azure, with Azure Container Apps, obviously, also on that slide. So we have web apps for containers. I think everyone who works with Azure and is some kind of developer knows about app services that allows us to, deploy APIs, web applications, and stuff like that into the public cloud on a platform as a service layer. And on app services, we can also run containers. So we can run single containers, multi-containers, like you, for example, use locally when you use Docker Compose or so. So this is a great starting point for teams that are adopting cloud and want to, grow on the journey of moving into the cloud. From real-world projects, there are some pitfalls when it comes to web apps for containers. So I see a couple of teams starting with web apps for containers and quickly trying to move to Azure Kubernetes Service, or AKS. which is a fully managed Kubernetes service. So we just have to take care about the worker nodes. All the control plane stuff is handled by Microsoft, and we can, if we want to, pay for an SLA to get an guaranteed availability. So this is obviously the rock star on the picture until today. And there is Azure Container Instances, which is great if you have, for example, long-running background processes, which don't have to start like in seconds, right? Because what we see on what we stumbled upon and what we saw in almost every project is that Azure Container Instances need some time to pull container images and to fire them up, especially when you're working with Windows containers. Keep that in mind, that it can take several minutes until your Windows container is up and running in Azure Container Instances. Yeah, and then obviously the new kit, Azure Container Apps, which is a nice addition to that landscape. There are obviously other services that are also able to run containers. But yeah, for today, I would want to focus on, let's say, typical web applications that we want to host in Azure. And so those are the 4 opportunities that Microsoft provides us. All right, with that, let's fire up a quick poll. So I would like to know if somebody of you is using containers in production, and if so, which of those services you're using to host your containers. Or if you are not using containers at all in production, then there's also an option for you. So please take those seconds and give me a vote. We will come back to the results of the poll later. Okay, that said, so we know, okay, there is a need for something like Azure Container Apps. So what brings Azure Container Apps actually to the table? Well, it's a serverless platform to run containerized applications. Surprise, surprise. The good thing is that we as customers, we will be charged on our actual consumption. So that means when we run a container, we consume obviously memory, and we consume CPU computation power, right? And we get charged actually on that consumption. So this allows us to to move our costs to operational expenditure and to have maybe run apps cheaper compared to, let's say, full-blown Kubernetes. Azure Container Apps is built on really powerful and popular open source projects that most of you, if you are in container space, already know and maybe already use. So obviously there's Kubernetes under the hood, and Azure Container Apps hides a lot of the complexity from us as developers or as DevOps team members, right? So on top of Kubernetes, Microsoft took 3 open source projects to make, that serverless experience and the ease of, deploying applications into Azure Container Apps happen. First, there's Envoy, which is an Ingress Controller, which is used, to route requests from the outside, on towards your containers. Then there's Dapper, so the distributed application runtime that we can use to build microservice applications. And there is Keda, which is Kubernetes event-driven architectures, which is a nice add-on for Kubernetes that allows us to scale several containers or pods in Kubernetes automatically based on actual load, which speaking about load, I mean about contextual load. So for example, let's say you have some kind of container that has to respond to events being populated in, or to messages being populated to a message queue, then KEDA allows you to define thresholds when Kubernetes should start, scaling out that component to deal with a higher load. And if the load drops on a message queue, KEDA can automatically instruct Kubernetes to scale in again, so that we don't mess around with compute resources. All right, so that's basically what it is from a technical point of view. So it is a Kubernetes behind a certain, right? We have some additions that allow us to build our apps quicker and to simplify, let's say, the 80-20 rule, right? 80% of the use cases of typical web application use cases will be easier to deploy and to operate in Azure Container Apps because of those, because of the basement, right? Because of those open source projects. Which leads to the question, okay, which kind of apps can I run on Azure Container Apps? So obviously you can run web applications, so everything that has some front end interacts with an API, or if you're an API provider, you can run your HTTP APIs in Azure Container Apps. You can run any kind of microservices architecture in Azure Container Apps. You can run background jobs, recurring tasks that has to be executed once a day, once a week, or in whichever cadence you want it to be executed. And due to KEDA being part of Azure Container Apps, you can build and run any kind of event-driven applications. We will pick up event-driven applications in a couple of minutes again, and see, or I will give you some examples of what's possible there. So that's what you can run in Azure Container Apps. But the interesting thing is, for many developers, how is it different from when interacting with Azure Container Apps compared to interacting with, let's say, good old Kubernetes, no matter if it's on-prem, on bare metal, or if it's in a public cloud, right? So in Azure Container Apps, so I've grabbed that drawing from the official documentation, we have a concept of so-called environments. And an environment is basically the first resource that you will create when you want to use Azure Container Apps. And the environment is a kind of boundary that spins up, that integrates with the Azure Virtual Network infrastructure. So that allows you to, or that guarantees that there is built-in security on OZ layer 3 and 4, right? Because your workloads will always be grouped together in a container app environment. And in a container app environment, in the most simple example, we will have just one container app. And container apps can have multiple revisions. But again, in the simplest scenario, there's one revision or one version, which consists of a pod. Pod is a concept that we know from Kubernetes. It's basically a container, let's say, on steroids, right? So a pod can have multiple containers being executed on the same virtual host, so that those containers can interact or communicate with each other as you would execute them on your local machine. And basically that's it. So we need an environment. In that environment, we create a container app. On that container app, we can configure things like how's networking, or how should networking behave, and stuff like that. And then we must have at least one revision, which represents, let's say, our sample API, or the hello world example, as we will see in a couple of minutes. And if if you have multi-container or more complex application that you want to host in Azure Container Apps, as the picture shows, we can just add multiple container apps to the same environment. So then those container apps can communicate with each other. And this leads us to one of the building blocks, which is the Envoy Ingress proxy. So an Ingress controller, Ingress controller obviously is responsible to route HTTP or network requests to services running in Kubernetes. This allows us to, for example, expose our API to the public. And in Azure Container Apps, we can also define if we want a service, so let's say a container, being able to accept incoming connections either from the container environment or from everywhere, so that you can call it from the public internet. The nice thing is that we can do some advanced configuration and can implement things like traffic split, where you, for example, have your production environment. 90% of the traffic should go to production environment, and 10% of the traffic of the requests should go to a preview version. This can be done easily in Azure Container Apps by implementing a so-called traffic split. That's totally optional, but it allows you to, get things like that up and running in minutes. As I said, we can expose apps internally, and I have a sample that we will, which uses exactly this one. But from a conceptual point of view, it's nothing different than a regular Kubernetes service that we can, call via a full qualified name. So I put a sample over here in the slides. So we can, by allowing internal ingress, we can, connect multiple containers with each other, and can, do things like provide a facade API with some downstream services, and then only, the facade is able to call into those downstream services. So that's easily possible. Next is microservices. So Dapper, maybe you have already heard about Dapper. That's an it's distributed application runtime. Basically, it's a collection of sidecar containers or components that you can run besides your actual application container, which gives you, or which brings typical cloud native, let's say that way, functionality to the surface, right? So, for example, let's say you want to persist some kind of state in a Redis cluster. You, as an application developer, you don't have to deal with a Redis SDK and stuff like that. So the Dapper component for state persistence, there is an implementation for Redis. So all you need to know is that there is a Dapper container which gives you an HTTP or an gRPC API that you can easily call, and that dedicated sidecar container offered and provided by Dapper, takes whatever data you send it to and stores it in a configured Redis cache. So Dapper is really cool when it comes to building cloud native applications. But the important thing, you can use it with Azure Container Apps. It's integrated by default, and it's super easy to get started with, but it's 100% optional. You don't have to use Dapper in Azure Container Apps if you don't want to. And that's really important, because that's for a couple of developers that were looking into Azure Container Apps get confused. So do I really have to use Dapper at that point? Short answer, no, you don't have to use it. Okay, a couple of slides back, I said you can run any kind of event-driven applications. Any kind. Well, obviously, KEDA allows us to build event-driven applications in Azure Container Apps. And KEDA comes with so-called scalars. And scalars are like, let's say, small connectors that we can use and instruct Kubernetes to scale, for example, from 0, so nothing happens, to, let's say, 10 instances of a worker service that should respond to messages in an Azure Service Bus queue, right? So we can, spin up or scale depend on contextual load. And those scalars are not limited to Azure or to public cloud systems, right? There are around about, I think, 27, 28 something official KEDA scalars available. So there are things like Redis, like Apache Kafka, like Amazon services, like GCP services. So it's really, again, it's a project under the umbrella of the Cloud Native Computing Foundation. So it's not 100% tied to Microsoft. It's more about, solving that issue or building event-driven applications in Kubernetes and in Azure Container Apps easier. So those are the, let's say, basics of Azure Container Apps. But the question is, what can we do with it? So for example, I want to switch back to, let me quickly dismiss the model dialog over here. Okay. So let's switch to Visual Studio Code, and let me quickly fire up the deploy script because it takes a couple of seconds or minutes, and then we can go for it. So I have created an hello world. Microsoft offers you see a container image that says Container Apps Hello World, which gives you a nice, JPEG being displayed via HTTP. So great. But how can we run that in Azure Container Apps? So first, obviously, it's in preview, so we have to add an extension to Azure CLI in order to, being able to interact with Azure Container Apps from Azure CLI. So although the link looks a little bit cryptic, it's a link that's provided in the Azure documentation. So you will quickly find that link on the first pages in the official docs. Then, if you have not yet, you must register Microsoft.web, so that provider must be registered in your subscription. This can also be done through Azure Portal or other management interfaces, but those are the requirements, right? So I skipped this one because I have already installed that extension, and checking if the provider or registering a provider just verifies if it is already registered. So that's not a problem, executing that twice. So then we have some, configuration stuff. Then we create a resource group, and we create a log analytics workspace. Log analytics workspace is required by Azure Container Apps because all logs, no matter if we talk about infrastructural logs or if we talk about logs that you as a developer write to your standard error stream, those will be collected and sent to Azure Log Analytics Workspace. So we create a new log analytics workspace, and then we can create that container app environment, right? So we give it a name, we place it in a resource group, we link it to the log analytics workspace, so that we just have to do that once. And then all the container apps in that environment will automatically log to that log analytics workspace. Quickly check the clock. Okay. Last but not least, we say, hey, I want to create a container app. Give it a name, Hello Akka. In the resource group we created previously, in the Azure Container App environment we created previously. And then we say, hey, there's a Docker image somewhere. In our case, you can see it's on a public Docker registry offered by Microsoft. And this image exposes or allows incoming requests on port 80. So we want to have Azure Container Apps forwards requests to port 80 of our Docker container. And we want the Ingress to be configured to allow requests from the outside of the Azure Container App environment. So we set Ingress to external. And then there's some, addition just for demonstration. So I immediately query for the full qualified domain name so that I can print, hey, our container app is up and running on URL. And here we go. Let me quickly fire it up, and yeah, now it's on the wrong screen. There we go. This is our hello Azure Container Apps running up in the cloud. Okay, let's take a look in the Azure portal. So there's a hello Akka. That's the resource group we created. Then we see there's a container app environment, and there's our container app. Let's quickly dive into the container app. So during preview, we have some fundamental or some basic, representation here in Azure portal. But what you can see already is that we have the possibility to specify secrets. So these are plain old Kubernetes secrets in the current state of Azure Container Apps, right? So if you, for example, need a connection string to go to your database, then we can add those information also to the deployment command and get those sensitive values stored over here directly attached to the container app itself. Then we have the Ingress configuration, and you see that Ingress is enabled. So we want HTTP requests to find its way to that container, and it's external. So everyone from everywhere we can call it, and then it should be forwarded to port 80. Obviously, we can, spin up GitHub Actions, Azure DevOps pipelines to get continuous deployment, but that's beyond the scope of this webinar. But then we have revision management. For every time we deploy, we get a new revision. And then we can, over here, traffic, we can control how many percent or how much traffic will be forwarded to that particular revision of our container app. So this is really, really cool and makes, having multiple or implementing traffic split really easy. But again, it's optional. You can also say, hey, this is only, no matter what's happening, how often I deploy the container app to that app, or how often I deploy a container image. There's always just the latest version. Please route the traffic always to that one. All right, so let me quickly delete this one again, because in the preview, we are limited to have 2 Azure Container App environments per Azure subscription. And yeah, I have 3 samples, so we have to get around that limitation. Okay, let's go back to the slides for a couple of seconds. So spinning up a single container application is really easy. And I've used Azure CLI to achieve that. But in a real world scenario, we want to, do that professionally, right? The good thing is Azure Container Apps is built on top of Azure Resource Manager. So it's, you can do all the things with the Azure Container Apps that you can do with other services that you may know from Azure. So you can put tags to it, which plays again into the governance story of your organization. You can deploy Azure Container Apps to certain regions or locations. And because it's based on Azure Resource Manager, we can interact with it via the ARM API. And the ARM API is obviously used by infrastructure as code tool sets like Terraform and Bicep. So Project Bicep is, as of today, the best story to provision, to manage, or to govern Azure Container Apps, because it allows us to configure or control every aspect of a container app or the container app environment. Pulumi, I think Pulumi has already also a story already for Azure Container Apps, but Terraform is still lacking support of Azure Container Apps. So there is an issue that is actively tracking the state of Terraform finally getting support for Azure Container Apps. So yeah, that's still sad, but as of today, I would say Project Bicep is my way to deploy Azure Container Apps. Azure CLI, as we saw, is great to get started with it, to get some hands-on, to play around with the service. But for real scenarios, you want to have a robust infrastructure as code story. All right. So I took a container image provided by Microsoft. I can also grab an image from Docker Hub, but in an enterprise context, typically our container image must be protected and they are not public. So we can use container registries like ACR, like Azure Container Registry, or Google and or GCP and AWS. They have competitors. Obviously, you can use those too. But integration, Microsoft is always good when it comes to integrating their services with each other. We are still early in preview. So we have to authenticate against ACR, for example, with username and password. That means you can enable the admin account on an ACR instance, but that's definitely an anti-pattern. I would recommend you using an ACR premium on a premium SKU. And then you can create so-called scope maps and tokens that you can also revoke later on easily and provide those credentials to Azure Container Apps during deployment. That's just because managed service identities are not supported yet. So there's also an issue on GitHub where the progress of this one is tracked, but today, we must provide credentials if we want to interact with a protected container registry. We can easily do that in Bicep by just linking the username, password, or the token and the password from the ACR to Azure Container Apps. Okay, monitoring, as I said, it's already integrated nicely with Azure Monitor. So Azure Monitor is, the let's say the umbrella product, and underneath Azure Monitor we have Azure Log Analytics, which is used by Akka to stream the logs there, and we as users we can just dig into the logs by using Azure Monitor and ask for, let's say, the output that particular container produced on the standard out. And the good thing is the logging agents running in Azure Container Apps enhance or enrich every log with contextual information. So you always have a column that says, hey, this is from that container app name. It was that revision. It was that container image, and so on and so forth. So it's enriched with important and necessary contextual information to allow us to do proper troubleshooting. Okay, there was enough time in the slides. Let's quickly jump back to VS Code. So next I want to take a look at another fairly simple application. Let me quickly fire up again the deploy script. So the deploy script is fairly different compared to the previous one. We just create a resource group and then we fire up a deployment. So basically I have coded everything in Bicep because that's the preferred way how you can get, or how you will get your containers up into Azure Container Apps. So from a provisioning point of view, we will end up in having a regular standard deployment in our resource group, which will, deploy several things. Again, we get a log analytics workspace. So it's not really much happening over here. We have our container app environment. And as you can see, I've defined a couple of variables that allow me to reuse that Bicep script for different applications. So that may make it configurable from the outside. But key over here is the akka.bicep. So that's the definition of the ARM resource or the ARM entity that represents a container app. So we have several metadata, right? Like, for example, how we want our ingress to behave and the template, right? So our container app consists of at least one container, which is defined by a container image and its tag. We can give it a name, and you should give it a name if you run at least or more than one container. And we can specify environment variables. We can bring in secrets, as we saw in the portal earlier. And we can also define scaling. All that is defined on the Azure Resource Manager entity, which makes deploying so easy. We don't have to deal with, 100 or 10 different, entities from Kubernetes, for example. So everything is, combined into that Azure Container App entity over here, which will obviously, evolve over time. And yeah, we're still in preview, yada, yada. But we have just that one thing that we must take care of. So if we look at the main file, so the main Bicep file is just, referencing those modules. So basically we say, okay, we get this deployment will be invoked in the context of a resource group. And then we specify the container image on which port it accepts traffic. Then we configure the log analytics. We configure the Akka environment, which, uses the client ID and client secret from the log analytics workspace that got provisioned right before that. And once the environment is there, we say, hey, please spin up a new container app, name it paint, name the container also paint. In the location that is specified on the resource group, there's the app environment. This is my container image, this is my port, and there's just for demonstration purpose, right? I set a simple environment variable, and we want to allow, external, so that we are able to interact with our example. Quickly switch back to Azure Portal, refresh that view, and you see there's Akka single container, and there is our container app, which is paint, and there we got the application URL. Let's open that one in a new tab, and as you can see, we can easily use our web application right now being served from Azure Container Apps. So nothing different, very similar to the Hello World app, but in this case we are using Bicep to deploy the application. Okay, which leads me to the third example. And the third example is a little bit more advanced. So it's an application that consists of basically 3 containers. So we have a facade, so that is able to accept incoming calls from the internet and call downstream APIs. So one of them is the order service, and the order service will, persist state in Azure Cosmos DB and read state from Azure Cosmos DB, where the other downstream service is the inventory, which is just faking an inventory service for demonstration purpose. I've written that example in Golang, but it's not, you can use any language that you want to build applications. And I've used Dapper to integrate those containers. So this is also totally optional. But let me quickly bring up the order service. And I think also if you have never used any Go programming language, that should be easy to follow. So for example, let's take a look at the create order. That's a handler for an HTTP request. And we where do we go? Okay, so we read the request body, so the payload that the user sends to via HTTP post. And with that body, we just take that body and say, hey, Dapper, please save the body in an orders table or collection in Azure Cosmos DB. And if everything went well, please give me a status code of created and the ID of the order. And if something bad happens, give me a HTTP 500. So nothing fancy here. If we go to the main file, scroll down a bit, where have I configured? It's a couple of weeks ago. So where have I configured my API endpoints? Main, there we have to get order, there we have to create order over there. So we have basically two routes, right? We have get order by ID and create an order. I don't know why I have an ID over there in the route parameters, but yeah. So basically two HTTP endpoints. The facade, that's the other interesting thing, has an hello endpoint, just an echo, right? Then we have, hey, give me create an order and give me an order by ID. So we manipulate the API interface because from public API surface, we want a cleaner API. And we have an inventory. So give me inventory of an item by the item ID. And if we look into the handler over here, let's again take, for example, get order. We check if there's an ID. If ID is not set, then we say, hey, not found. Could also be a bad request, right? And if there is an ID, we create a new HTTP client and just call the Dapper container that is running besides, in that case, the facade, and say, hey, please call something that's called orders with that ID. Right? So it's loosely coupled. So all the, the coupling to Azure Cosmos DB and the coupling between those three containers is all done again. Let me bring up this one in our deployment manifest. So we see, for example, there's an Akka that's the same thing, just, I bound more parameters over here. So the order service has a container registry, username, password, stuff like that. And we have a Dapper components configuration area over here. And we say we want orders, that is state, we want to persist or read it from Azure Cosmos DB. We provide an endpoint, a database, and a collection name, and yeah, some sensitive connection information, which is a secret in that case. And we register, let me quickly check this one, in the facade, we register order service name and inventory service name. So everything regarding deployment, regarding interaction, and so on and so forth is combined into our deployment manifest, let's say that way, which makes it, very, very focused to even configure multi-container applications. So let's give that a try. I have already deployed it because it takes a couple of minutes, right, to spin up that multi-container application. And you see there are a couple of more things happening over here. So we have the container app environment. we have 3 container apps. We have the log analytics workspace, nothing new. Then we have application insights, because one of the components want to write also to application insights. And we have a Cosmos DB account. So the Facade API is the one that has Ingress, being configured as external, right? And we see maybe we have, no, on that one, we have secret, to pull the container image from a private registry. But the important thing over here is we have a public domain. So I've configured, and that's also in the Git repository, I've configured a Postman collection that allows me to quickly, place the root URL. If I go over here and say, I look for the edit button every time, edit. So you can set the public endpoint as a variable. There's an order ID. We will talk about it in a second. So having the correct root URL, we can say, hey, I want to order 2 times item 12 and 5 times item 2, and I can just send it. So we got an ID of 979 something, and I have a test created over here that takes the response body and sets the order ID as a variable on that collection, which I then use again in the get order to verify that the order has been persisted in Azure Cosmos DB. So I can invoke, give me the order by ID, and we get back 12, 2, and 2, 5. Let's do the check again. So what was it? Was it 9797? Okay, let's go to Azure Cosmos DB. Azure Cosmos DB orders, items, and there we go. There it is. Come on. So as you can see, the value is base 64 encoded. So we can just grab that value. See, the ID is prefixed with order API over here, but that, it's a Dapper thing. Let's bring up VS Code, and let's clean up this one, and let's say echo-n, paste in that one. And let's do base 64 decoding, and you see that's the actual value as base 64 representation being stored in our Cosmos DB instance. So also we can run multi-container apps easily in Azure Container Apps. And the last demo that I want to do is, let me go to Azure Monitor, go to logs, select a scope. Come on, I don't know if that's the right scope. Let's quickly check. It's that's log, and I tested that already yesterday. So as you can see, there's a container app controller logs table. So we can say, just give me all the data from this one. Let's say order by time generated desk ending, and we get the most recent outputs on the top. And as you can see, we see which container app has created that entry. And we can also see, if we scroll a little bit further to the right, which container name did produce that console log and to which stream did it send that log. So, I mean, Facade API, that's obviously the interesting one, right? Because I know that there's something written. So let's say where container app name as equals Facade API. And let's quickly verify. Okay, we still get some logs. Let's sort them, order by time generated disk. But the problem is over here that again, we got a bunch of logs from Dapper D, so from the Dapper sidecar container, but we really want them from our container. So we can say and container name as equals again Facade API. So that's the name for the container in that container app that I specified. And as you can see, there are just 2 logs being written in the last 24 hours. And where is the log S? Did I scroll? Okay, there is successfully written something bytes to response body. So somewhere in my Go code, I read that log to standard out. So diving into, although we are still in preview, diving into the logs for every container you deploy to Azure Container Apps is easy and straightforward with Azure Monitor, and you can create tailored queries that help you troubleshooting, investigating, and actually seeing what's going on behind the scenes. All right, let me quickly bring up the slides. Before we wrap up, I want quickly to revisit the poll. Göran, what was the outcome of the poll?
Yeah, actually, there's a small number using Azure Container Apps at the moment, and then it's near the same level for web apps for containers, container instances, and Kubernetes servers. It's the same. It's
So it's a balanced.
16% to 20%. It's
okay,
quite
so it's
balanced.
Yeah. So my bet is that Azure Container Apps, especially for those of you who haven't used it yet, may be interesting. I mean, you have to match the capabilities to the requirements of your application, but for let's say the average web application / API thing that you want to host or run in a container in the public cloud, I think Azure Container Apps could be an option. And it's definitely something you should keep in mind or track in the upcoming months.
Yes.
Which leads to conclusion.
Yeah. Just give me a second. That point you just told. Maybe they will bring in the other ones who who don't use containers at the moment to use containers.
You mean as a transition? Yeah, maybe.
Yeah, sure. Yeah, because this topic is showing that it's quite easy to jump into containers and cloud offerings. Yeah, but go on.
Okay. Yeah, it could be a good opportunity, to modernize or containerize your application and get it hosted on a serverless runtime. The good thing is there's always an eject button, right? You can always take your container app or everything you deploy to Azure Container Apps, and you can run it in Kubernetes. Obviously, you just have to. You have to, rework the deployment manifest a bit. So you have to, dive into YAML and specify your deployments in YAML and fire them up to against your Kubernetes API server. But that's always possible. I think, maybe it's enough for, let's say, 80% of the workloads, so typical web workloads, but we will see. Overall, the integration with other Azure services must or will become better. At some point, it must have to become better. And I have summarized a little bit my feedback up until today. We are still early in preview. Obviously, preview means there's no SLA, and there are important things missing, right? So every Azure Container App environment has its own virtual network infrastructure, which ensures your workloads are isolated from the workloads that other customers run there. But I want, for example, bring my own virtual network, right? Or give me control over the underlying virtual network infrastructure, things like that. I can use secrets, as we saw right before, having the Docker password. That's great. But please give me secret store, a CSI driver for secret store to integrate nicely with Azure Key Vault and others. There are tons of services that you can integrate and ensure governance, to ensure you met requirements or you met the requirements offered to you as a developer by your IT or security department. But again, we are early in preview. The Azure team is very open-minded, so the roadmap is publicly available. I know that virtual network, so bring your own virtual network or give me access to virtual network infrastructure, is top of mind actually at this time. So it's worth checking the Git repository from time to time, and if you stumble upon some issues or glitches, help them to land that thing. So please contribute, submit your issues. Guru and I, we did it yesterday because we stumbled upon another small issue. Be nice and help the team landing that serverless service, because I think that's really worth it. And with that, are there any further questions, Göran?
Oh, yes, we got one.
Okay, let me quickly switch to the camera view. There we
I can
go.
do that for you.
Okay, there we go.
Okay, Stefan wants to know if Akka can be reached via gRPC.
That's a good thing, a good question. I think so. I think I saw already a gRPC sample. We can check that.
Okay.
I mean, internally, yes, of course. I mean, that's not a problem. But the egress, so far, I don't know if there is any service sitting between the Ingress controller and us as consumers that would prevent gRPC from working. And if I remember correctly, I stumbled upon somebody who deployed a Blazor with gRPC stuff to Akka a couple of days or weeks ago.
Well, Stefan, maybe you want to give a shot with Thorsten in the expert one-on-one, so we can make use of the 20 minutes to have a look into that. And
so, HTTP2 is definitely, that's possible.
Yeah. Let me just bring up the registration again. So if you missed out, you can do it now, or afterwards, we will send you an email with the recording and everything. The registration link will be included too, so no hurry. If you run into any questions after the webinar, it's not too late.
So there's another question from Tim. I just ran through the questions. If it is possible to integrate Akka with Azure Service Bus topics through Dapper, that's a good question. For Dapper, I don't know if there is a Dapper component for Azure Service Bus topics, but at least you can use it for you can scale, obviously, based on the topic with Keda. Let me quickly check Dapper, because it's always interesting, right? What's possible with Dapper? So they have pub/sub components. So Dapper is offering pub/sub components. Let me quickly check. Developing building blocks. So there is pub/sub, and pub/sub supports.
Should I switch to screen sharing again, Thorsten?
No, not. I don't think that's necessary.
Okay.
Just double checking. Message queuing. Pub/sub without, so they provide a pub/sub component that's able to talk cloud events, and I think that they have bindings overview, input triggers for Kafka. What else do we have? Sometimes it's hard to, let me quickly switch to the screen. Come on. Sometimes it's hard to, so pub/sub, how to publish topic to topic. Okay, so which one? RabbitMQ, okay. but they offer. Sometimes I'm just always looking for the reference, right, to see the API reference. So it pops up, and we have metadata. Quickly check. Yeah, that's the one we were. And let's say actors. No, that's actors. We have the bindings. We have the integrations. Is it there? Azure and logic apps, functions, runtime. Well, not 100% sure. I have to reference Dapper component specs. So let's quick look at pops up, and there is Azure, Amazon, GCP, Azure Service Bus, and we have connection string. And is there something topics node across all topics? Save entry. Yeah, so there is a guide that explains how to configure Dapper to integrate with Azure Service Bus topics. So that should be possible. And the second question by Tim, or more an opinion, Azure Functions as a better fit versus Azure Container Apps. Well, that's different things, right? Although Azure Functions is also serverless service, right? It requires adopting or using the Azure Functions programming model. And in contrast, you have the freedom of choice in Akka, because you can use whatever you want in your container, and you're not limited to, yet, let's say, binding, triggers, outputs, and idioms offered by or provided by Azure Functions. So personally, from my point of view, I'm more in the Azure Container Apps corner than in the Azure Functions corner, although Azure Functions is great depending on the actual use case. But for HTTP-based APIs, I would always choose something different than Azure Functions. But yeah, it depends actually on the context. All right, yeah.
Okay. That's it for the Q&A section. I think the rest of the questions will be in the expert one-on-ones.
Yep.
So this will be fine. Yeah, I think that's it for today.
Yes, sir.
Thank you for attending. Thank you, Thorsten, for your knowledge and sharing that. Maybe I see you next week in the webinar of Patrick. He's talking about Blazor, WebAssembly, and what's new with .NET 6. So have a great day, stay safe, and yeah, see you next time.
Have a great day. Bye.